lesson 4-7. Today we're going to be talking about scientific notation. So with scientific notation, that means we're going to be dealing with really big numbers and really small numbers, and we're putting them in a different form. Now, why would we put a number in different form? So the reason why this kind of scientific notation or a way to write numbers was come up with is because it makes it quick and easy to deal with both huge numbers and small numbers. So basically, instead of having to deal with numbers with this many zeros or anything like that, it's a lot harder to deal with those than it is to deal with something like this. So basically, people who use numbers all day long and stuff like that, and who use them in their work and stuff like that, they need to write it in a simpler way for them so that they can just make it quick. So they don't need to be spinning numbers doing it with all these zeros. So they write it in a different form, which is a scientific notation. So what are some of the rules of scientific notation? Because of course there has to be some sort of rules because we have to have consistency in math. So everybody needs to be doing the same thing, so we have to have rules so that we can have consistent answers. So a number less than 10, so once you finally write out your number is going to be less than 10 and greater than or equal to 1, and it's going to be multiplied 10 raised to a power. Now it sounds like gibberish, but this is what it means. So basically, this huge number, when you write it in scientific notation, you're going to have a number that's less than 10. So there needs to be a number in the ones place. And it needs to be greater than or equal to 1. So it is. So we don't want 0.5 because that's not a number greater than 1. So we have 3.5, so 3 and 5/10 times, it says multiplied by 10 raised to a power. So this 10 is raised to a power. Now the reason why this 10 is raised to the 7th power is because we had to move the decimal 7 places to get to where we put it. So it's the same number, just written in a different form. So here are some more rules. When the exponent is positive, that means we're talking about a big number. So we're talking about a big number. If it is negative exponent, we're talking about a small number with a decimal. So just like we talked about last lesson, where we talked about negative exponents and manipulating them from the numerator to the denominator and vice versa, that's what we're talking about here. If you have a negative exponent, it means you're having a fraction of something, a part of something. So that means it's going to be a small number. It's going to be some sort of very small decimal. Not just 0.5, it's going to be like 0.0000000 something. So in order to make it easy, we write it in scientific notation. Now let's talk about how we get numbers into scientific notation. Alright, so how do we go from standard notation, which is just written as a number, to scientific notation? So with the decimals multiplied by numbers raised to powers. So how do we get from one to the other, and how do we make sure it's the same number? Alright, so if you're talking about big numbers, numbers that just have many zeros, it's in a very far place value, how do you deal with those numbers? Alright, so first of all, you have to recognize that you're having a big number. So that means that it's going to be a number raised to a positive power. So get that in your head right when you look at the number. Big number, positive power. Then we're going to go ahead and move our decimal. So we're going to move our decimal behind a place value that we want to be the ones place. So we want to move it to where there's one number left of the decimal. So we're going to go 1, 2, 3, 4, 5, 6, 7 places. So now we forget all those zeros because the whole point of this is to get rid of all that long numbers, all those zeros, and to make it more concise and short. So we're going to write it as 7.53. So here's 753. We got rid of all those zeros, put that decimal place where there's a ones place only. We don't want 17 or anything like that. We just want 7. So 7.53 times 10. So we're working with tens because remember, anytime you're multiplying by tens, dividing by 10, it moves your decimal place because we are in the base 10 system. So we have times 10 raised to the 7th power. The reason why we have it raised to the 7th power is because we had to move our decimal 7 places to get where we want it to be. So it's 10 raised to the 7th power, and again it's positive because we're dealing with big numbers. Now, how do we deal with the small numbers? So now instead of our decimal being way to the right, it's way to the left. So how do we deal with that situation? First of all, we look at it and we say, this is a really small number. There's a decimal. So we're going to be using a negative exponent. Because remember, negative exponents are a part of something. It's a fraction, a portion of something. So we're talking about a part of something because this is not a whole number. All right, so then we are going to go ahead and move our decimal place. Remember, we want one number to the left of the decimal because we want a ones place value and that's it. No tens, no hundreds, just ones. So we're going to go ahead and move our decimal over 1, 2, 3, 4, 5 spaces to get it where we want it to be. So now instead of 0.0000429, we are going to have 4.29 times 10 to the negative 5th power. So remember, our power comes from how many times we move our decimal. So if we moved it 1, 2, 3, 4, 5 place values, it's going to be the negative 5th power. Negative because we're dealing with really small numbers. Now, try to get it to where you can understand it. Don't try to memorize going this way and that way means positive or negative. Understand that when we're talking about negative place value, in order to make a negative power positive, you have to put it in a fraction form. So remember, if we have 5 to the negative 3 power, you would have to write it as 1 over 5 to the 3rd power to make it positive. So this is showing us that we're talking about a fraction of something.